Today we will talk about continuity primarily and intermediate value theorem. So let's go and define continuity first. The definition is f is continuous at a point A when the limit as x goes to a of f of x is the same as f of a. Let's look at some points at this graph, 1, 3, and 5, where some funny things are happening. At 1, the function is not defined, even though there is a limit. So this part of the definition does not work. Therefore, it's not continuous at 1. Let's look at 3. At 3, the function is defined. There is the black dot at 3. So it is defined. This part of the equation works. But the limit from the left and right do not match. That means this part doesn't work. Therefore, this is not continuous at 3. Let's look at 5. There is a limit from the left and right, and they match. Therefore, this part of the equation works. And f of a also is defined. Here is a dot. But the problem is they are not the same. Therefore, it's not continuous at 5 either. So let's look at a case where we have an f of x defined at x squared minus x minus 2 divided by x minus 2. So I'm going to go and enter that. Let's use the equation. I push y. And I put the left parentheses, and I use this button for x squared minus x minus 2 close parentheses divided by x minus 2. If I want to take a standard zoom, I have to go to the zoom menu, and here's the zoom menu, and the selection is zoom standard, 6, push enter, and it's going to draw a line. Okay, it looks pretty continuous to me. But how do I know that there's a hole or something funny is going on? So I have to use a hybrid approach and look at algebra also. So let's look at this. If I have this equation divided by this, and I know that it is not defined at 2, one way to find out is use this calculate value function. When I push second calculate, it's going to bring up a drop-down value, and there is this value function. Push enter to get that. Let's look at the value at 2. Here we go. And push enter. Guess what it does? It does leave it blank. That means there is no value at 2. That means there is no value, and it's not defined at 2. Remember, one part of the equation does not work. Therefore, it's not continuous. So one way to recognize this is just to see this blank in here. When you look at this and when you factor this out, you know that the x minus 2's are going to cancel out, and you are going to have an x plus 1. Now, let's look at this function, and let's see what it does. X plus 1 is continuous, right? So I'm going to go and enter x plus 1 here. X plus 1. And I am going to draw that graph, and I'm going to make this inactive, and let's graph it. It looks like it is the same graph, isn't it? But there is a difference. Let me go get the calculate button, and then let me get the value. And when you put 2 in there, and look what is going to happen. It will go and find it, and it will display the value. Because there's a difference between this function and this function, even though they look the same. The top one, the y1, has a hole, and the bottom one, y2, does not. The first one is not continuous at 2, the second one is. And this is one way to recognize where it's continuous and not continuous. Now let's look at a case where we have a formula that is broken down into 2 parts. F of x equals x squared minus x minus 2 divided by x minus 2 when x is not 2. And it's 1 when x is 2. Alright, so let's kind of try to do this by hand. Remember, the limit and the f of f value have to match. So I'm going to take the limit first. When you take the limit, you have the formula. You first factor, and then x minus 2's go away, and now you take the limit, you get 3. So you have a 3 on the left, And f of 2, and remember how it was defined? F of 2 is 1 when x is 2. Alright, well 3 is not 1. Therefore, left and right do not match. That means f is not continuous at 2. Now, let's try to show this with your graphing calculator. You can enter conditional statements in your calculator in the equation, and I did that. You just push y and get to y1, and you enter the x's with this button, and you have to put a condition. Remember, the first condition was x is not 2. You can enter, one way to enter them using braces, and the braces are right here. You can put second, this parentheses, it will take the left brace, and you enter x with this button, not equal to. Where do you get that not equal to? You don't see that in here. You can go to second catalog. This is one way to do it. And it is alphabetical, A through Z. But if you go up, and it's going to have those symbol areas, because they're usually at the end of the A through Z section. I'm looking for not equal to. It will eventually be there. You see, not equal to is right here. So you can enter it, picking the enter button. Oops, that's what I meant. I didn't want to have. But, you just put it right here in this area, and then you're going to get not equal to 2. So I entered this part of the formula. This is just one point. One other way of entering things and let them display is using the statistics features. You can go to stat edit, and then I'll go to stat edit, and I'll enter that dot. And that dot is when x is 2, y is 1. When x is 2, so I'll put the 2 in L1, and in L2, I will put the y coordinate, which is 1. Alright, so it is a dot, right? Now, it can display this thing when you go to stat plot. You need to just turn it on, that's all. So you can go to second stat plot, and let's turn it on by pushing on and enter. It is a type of scatter plot. So you pick the first option, and look what I do. XL list, where did I put that? In L1. So let's put L1. And where did I put the Y? I put in L2. Let's get the L2. So I have L1, L2, and here's my dot. And if I do the zoom standard, zoom standard, I turned on the stat plot, and my equation, it should just put the dot, and it did, and put the line, and it did. Do you see it? So you can actually see it and understand that the function value and the limit do not match in your calculator. Another way of showing this in your graphing calculator is using the equation itself and enter that 2, 1 thing in the equation. And one way to enter that is just to specifically say, here it is my y1, and enter y2 this way. When x is 2, it's 1. Remember, I tried using braces, and another alternative to braces is to use a slash parentheses x less than or greater than or equal to or whatever. So that's the conditional entry. So I'm going to go to y2, and I will say, okay, well, y2 is 1. And I need to get that slash. The slash is in the catalog. When you go to catalog, and you go up, and you see all these symbols, and you can go and get the slash right there. Here it is. And say, well, left parentheses, x equals 2. Equals, it's not in here either, so I can go again to catalog and get those. And I have a habit of going to catalog whenever I don't find something. I always find it because catalog includes everything there is to, that's built into your calculator. Alright, here we go. The only problem with that one, when you graph, let me turn off the stat plot, because that dot comes from the stat plot, because I'm doing it the other way. So I will turn it off so that it doesn't interfere with what I'm doing right now, because this is the second way of doing things. And let me get out with the quit, and then let's graph. When I graph it, I don't see that dot anymore, and I actually don't see the dot at all. Well, how do I know it's there? Because the calculator has both of the equations active, but this one, because the pixels and the way the program is written, it doesn't display it. But there's one way to realize it's there, is use the calculate value function. Now, when you put x equals, remember things are happening when it's at 2. When I put 2 in here, look what it will do. It will go to the first one, which is y1. It will say, well, it's not there. Here it is. It's blank. Well, that's not what I want. I want it to go to the second one. So to get to that, I just push down arrow. Guess what happened? Now it went to the second one, and look, your value is here. So initially I didn't see it, and not only I see that little cursor here, I see 2 and 1. That means the function value and the limit do not match. This is another way of showing how discontinuities can be displayed in your calculator. I have y equals x squared plus 1 when x is greater than or equal to 2, and it's equal to 5 when x is less than 2. So I'm going to enter that. You take your x from this button, and then square plus 1. One way to enter it was with braces, so I used braces. Braces is right here above the parentheses. And greater than or equal to 2 button comes from the catalog. So I'm going to go and enter that. Catalog is right here, and you go and you find greater than or equal to 2. Let me show you where that is. Here it is. And also this less than, greater than buttons are there as well. Alright. And here's 5. Another way of not using braces is you use slash parentheses. So it replaces either the braces when you enter step functions, or you can put slash parentheses. And you enter this x from this button. Less than comes from the catalog. And let's look at the graph. So you see x squared plus 1. And here is 5. And you can go and you trace it. And tracing is a good way of doing this. And let's go up. Do you see it? X is 0. You can go to the right and all this. And here I'm approaching from the left. And here you are. It's 5. And you can do the same thing with the from the right thing. Let me go up a little bit. Okay, I was here. Now I'm approaching it from the right. Go. Look at the values down there. And it's approaching 5. Do you see it? Before it jumps, you can zoom in actually and see that. Therefore, this step function, this particular step function is continuous at 2. Now let's look at something else, and you can see it with the trace here. Let's look at this one, where I have x squared plus 1 when x is greater than or equal to 2, but it is 2 when it is less than 2. So let's go and change that value. Here is 2. And you can visibly see that. And I will push graph. And you're going to see this part first. And here it is. And there's a break. Obviously, it's not continuous at 2 for this particular step function. And so this is a little summary of how you enter step functions and where you get the buttons, and you can visually see how the discontinuity is displayed in your calculator.